Okay. First of all, I want to say something about the first video project. I almost grade everybody's. I have probably 3 people I haven't graded yet. Okay, so I think I have plenty to say from when I'm watching your videos. Okay. First thing is this: you are required to prove equations. Okay, so basically to verify a theory, to prove an equation. So I don't know if how is your math training in high school or before in the college in the calculus. I feel many of you not familiar with the process of proving theory. Okay. Let me say this. You are trying to prove an equation. Okay. Equation, there's an equal sign. Do you agree? Any equation, there's an equal sign. When you try to prove the equation, your job actually is to prove the equal sign stands. Does that make sense? Okay. So how do you prove the equal sign stands? So I don't know how many terms, depending on the equation. Equation could be short, could be long. Okay, could be 10 terms, could be just 2 terms or 3 terms. That's fine. So when you look at the equation, every terms. So for example, many of you do the surface tension. Sure. You have an equation surface tension with 2 terms. Force equals to sigma times length. Okay. So the process, the strategy is every term you have to measure it separately and see if they are equal. Okay. So ideally, theoretically speaking, okay, so F equal to sigma L. You probably need to measure the L. Okay, measure L. If you know sigma, okay, then you have to measure the force. Okay, so see if they are equal. Oh, okay, they are equal. That's good. The equation stands. I did my quantitative validation or verification. Okay. What some of you did is fine, but just missed the last step. For example, some of you did this. Okay, you know, you measure the length, you measure the sigma, you know the sigma. Then, okay, I use the equation to calculate F. Okay, or vice versa. Okay, you can calculate one unknowns in that equation, right? I agree. Okay, so what? That's not the end of the story. You haven't done any verification yet. Then you have to measure the thing. For example, you calculate the F based on the surface tension equation, surface tension force, okay? Okay, then what? You didn't do anything basically to verify experiment yet, unless you actually measure the weight, measure the force, which is the weight of the object. You have to have the scale to measure the weight, okay? Some of you did measure the scale, show you the kilogram or gram. It's a mass, okay? It's not the weight, okay? Newton, your equation is in the unit of Newton. Newton equals Newton, right? Force equal to sigma L. So you have to convert the mass into force, okay? You're an engineer, you have to be very comfortably dealing with force. Newton or pound force, depending on which unit system you use. Does that make sense? You calculate it based on that equation. You can measure something to calculate one variables in that equation. Sure, okay. You did that, but there's nothing verification yet. Okay, you don't know the value you calculate from the equation is correct or not until you measure it. Okay, everybody follow me here. This is the process of verification or prove an equation, okay? Again, as I said in the beginning, basically when you prove the equation has an equal sign in it. Okay, you're an engineer, you have to deal with equation a lot. Equation is not an expression, that's 2 words, right? If I say equation, there's an equal sign in the equation. And your job, if you wanted to prove the equation, your job is to prove the equal sign stands. So in that sense, you have to measure every term independently in that equation. Okay. Then if you see, okay, equal sign stands. Sometimes there's errors, you know. One term is not equal to the other. That's fine. Measurement has errors. Okay. But that's a process you have to take. Okay. Does that make sense? Anybody? You will do several more projects later. So you want to make sure you improve. Okay. That's one of the major issues here I see. Yes. Any questions?
Quick question.
Yeah.
I think I said as much in my project, but I don't have access to a force gauge or something like that.
Well, that's fine. At least you need to tell me. Okay, that's what I try to do. Or you based on the. So, for example, you know the metal, the material. You maybe find the densities from the internet. If you have a density times g, that's your mass.
Right, but I mean, I'm measuring an applied force. Like
listen, you don't need to measure that force. Basically, you if you can find the weight for that, or for your experiment, if you measure pascals, I think you did right. You did use a weight as the force lift. That's fine. That's a good way. Okay. So, but for other people, if you don't have the scale, go find the density. Right, rho v, that's the mass. Rho Vg, that's a weight. That's it. You don't need a scale even. Okay. Again, I want to say if you have the knowledge, enough knowledge, you don't need much of the equipment or instrument or whatever. You can always find the information you needed for your verification. Okay. That makes sense. But that's a process you need to do. Okay. I want you to verify a theory. So please be sure you know what to do next. Okay, the other thing I want to point out is buoyancy versus surface tension. I think many of you, 80% of you do the surface tension experiment. That's totally fine with me. But one thing, something float on the water doesn't mean it's by the surface tension. The buoyancy also can float the thing. Okay, some of you showed me, you pointed to the needle will sink to the bottom. That means, okay, the force supported it is indeed the surface tension. Some of you use very light material like plastic. Come on, plastic without surface tension, it will float too. So how do you prove that your force is from the surface tension, right? Be careful. That's a common mistake people make, okay? The other suggestion I give you is this kind of video project basically is for you to, just like a homework problem, you solve a problem. Okay, it's not like the middle school science experiment. Hey, I see something strange and this is good. That's not the end of the story. You have to actually solve that problem in front of a video. Well, you don't have to, actually solve it in front of it, but you have to show me, explain to me how you solve the problem. Okay, that's your explanation and the quantitative verification. Basically, you have to solve it. Okay, it's not like, okay, it seems like, hey, I put a soap in there. It seems like something moves. Okay, it's a surface tension. No, you have to solve it, how fast it goes. You measure the speed or measure the time it travels. Okay, and you have to use the surface tension equation, the theory we learned, to calculate it. If you cannot calculate that problem, change the topic. Okay, you have to show me you fully understand that problem. You do experiment and you know how to solve it quantitatively. Okay, that's one thing I want to mention. Some of you didn't do too well on that. Okay, couple of you exceed the time frame, 2 minutes to 4 minutes. That's easy. It's easy 1 point. I want everybody to get that 1 point. Okay, so when you watch the video, make sure that the length of video is appropriate. Okay, so that's one thing. Okay, force and mass, I already talked about it. Make sure everything eventually in the equation are all mass, okay, mass. So, I'm sorry, it's force. So convert the mass into force. Kilogram, gram, these are the mass, okay, not the force. Your equation is about the force. Okay. One thing is copyright material. If you use copyright materials, please be careful not to use the copyright material. Okay, don't get some. I think it's not good to get some video clips of something from movie or something, then you post it to your YouTube. I don't think that's a good idea. Be careful on these things. Okay. The other thing I want to mention is the safety. Okay, so this is small experiment. I don't think you're going to deal with high pressure, high temperature. But if you, in case, want to deal with high pressure and no high temperature here, right? So not heat transfer. In the heat transfer lab, if you do high temperature, make sure be careful and make sure follow the safety procedures. And high pressure also, if you deal with it, please you wear a goggle or something like that. But I don't think here we will deal with those things. Okay, but anyway, don't cut yourself. Don't be careful. Okay, so I guess these are what I want to conclude from watch most of your videos. Okay, is that clear to everybody? Any question I can answer here? Anybody? I think so far the grade is okay. You know, the highest so far I get is 85. I have probably 3-4 people haven't graded. 85 is the top score, and 45 is the lowest score. So most of you in between. So averagely about maybe 65, 70-ish. I didn't count exactly, but that's a range. Okay, so far. So yeah, okay. So I have a couple of people to grade. Okay. So I hope next time, the second video, you'll do much better. Okay, I will follow the same grading scale like the first one. So I'm sure you will do better, right? Okay. Okay. Let's look at, let's go back to let's share my screen to the notes last time. Well, let's continue on the velocity and acceleration.
Dr. Zhang.
Oh, yes, Seth.
I just want to inform you, I was late because we're having internet troubles at the school. Okay. And I'm at work. So if I'm in and out, I apologize.
Okay. Make sure you stay today. I will have a quiz, a small quiz, very small quiz.
No, I'm not logging out, but it kicks me off sometimes. So
yeah, I understand. Okay. But I think how many of you today? 15 or 14. That's pretty good attendance. We have like 18 students probably. So we will have a little quiz at the later part of the class today. So please stay in the class. Okay. Let me share my window. Okay, let me give you a quick review of what we have so far on the velocity acceleration. Velocity acceleration is basically the fundamental of the fluid mechanics, fluid dynamics, right? So everybody needs to know what is the process of doing measure velocity and acceleration. Velocity actually usually is measured, okay? If you have a chance to do fluid mechanics research or experiment future in your career, you will know most of the fluid mechanics experiment, people just measure velocity. Okay, velocity and acceleration. Velocity first. Velocity, acceleration, you don't need to measure. You can basically calculate it from your measured velocity. Acceleration can be calculated. Okay, I never see people, very few times see people directly measure acceleration. You don't need to. Okay, then later you probably need to measure force, right? Force, velocity, and the force. Eventually, the motion and the force are related. That's the dynamics. Okay, it's always the equation is between the force and the motion. Okay, so like for example, conservation of momentum, Newton's second law. What is Newton's second law? Remember? F equals
mass times acceleration.
Exactly, right? F equals mass times acceleration. Basically, that equation relates the force and the motion. Acceleration is the motion. Okay, so now you see that's how important we measure velocity. If you get the velocity measured, velocity field, right? It's not just one velocity anymore. In fluid mechanics, there's always a velocity field, okay? So you will have a relationship, velocity in terms of the location or time, okay? Then after you measure the velocity, then you can actually calculate the acceleration based on the equation we presented last time. Acceleration is also a vector, right? After you get the acceleration, hey, you can calculate the force, F equals to ma. Is that right? Okay. See, that's the process of doing fluid mechanics. Okay, doing any mechanics, basically. Motion and force. Okay. So that's a big picture. Okay. So, but acceleration is a vector. So it has also, just like a velocity, we have three components, ax, ay, and az. Okay. If it's a three-dimensional, ax, ay, and az. Okay. Just like velocity have three components, right? By convention, I think it showed here. Velocity components is u, v, w, representing x, y, z components. Okay. Did everybody hearing me clearly? This is a review. You probably will have a quiz later about this. Okay, please pay attention. Just want you to pay attention to everything. Okay, so three-dimensional ax, ay, az. These are the equations for ax, ay, az. Okay, so you see a problem, you ask yourself, it's 3D, 2D, or 1D. I have different colors here, right? The blue box is three-dimensional. Okay, if your problem is three-dimensional, ax, ay, az, three equations inside this blue box. 2D, smaller, green box here, okay? 2D, you have two equations, two components, ax and ay, so equation is shorter. 1D, even shorter, okay? You have only one component. If it's a 1D, you only have ax, okay? You only have two terms there, okay? So last time we also mentioned why we have the complicated form of the acceleration at four terms. Basically, the first term is the convective, the local acceleration. Okay, the rest of the term is convective acceleration. We use the example, this nozzle. Okay, is to show that at A, B, C on different locations, actually the flow is decelerating. You have acceleration here. However, if you use only the local acceleration, you don't see any acceleration. Okay, that's why we have the convective acceleration, the rest of the terms, which you don't see in the solid mechanics. Okay, that's the reason. With those spatial change of the velocity, your acceleration becomes non-zero. Okay, for these cases. That's why we need the long terms, long forms of the acceleration. Okay, so again, I want to say, hey, you need to know how to look at the acceleration equations. Everything is velocity there. Okay, the velocity u, v, w are expressions, just like I said it before. U, v, w are expressions. Each of them are function of x, y, z, and t. Okay. Then you need to know how to do the derivative in order to solve acceleration. Okay, you have a partial u, partial x, partial u, partial. You see, u, v, w are a function of x, y, z, and t. Okay, so after you take all the derivatives, then you can substitute the coordinates x, y, z, and t to find the exact value of acceleration on that particular coordinates x, y, z, and at the particular time t. Okay, that makes sense. That's a process. I think we did an example last time. Okay, 3D, right? 3D problems. I give you a vector form of velocity. Now you're an engineer. Now you have this class, you're better, right? You should be comfortable with the vector form of the velocity field. Okay, three terms here, I, j, k, right? The expression in front of I is u. The expression in front of j is v. The expression in front of the k is w. Okay? So you have the expression for u, v, w. Then acceleration is a piece of cake. Just take derivatives. Okay? ax, ay, z. You take derivative to give you a expression. Then you substitute the x, y, z locations. You can find acceleration on every point. On every point, you will have ax, ay, and az because acceleration is a vector. You have three components. Okay. You have to be really comfortable dealing with vectors. Okay. So Is that clear to everybody? Okay, just follow the process. You are going to be an engineer. Can you follow process? You can follow rules, right? I'm pretty sure, right? So following it, it will guarantee your good outcomes. Okay, so okay, let's look at a one real example. Okay, give you a example with physical dimension, everything. Okay, let's do it. See how you can do. Okay, the problem is this. I think it's a contraction. Yeah, it's a contraction. Let's see. Let me draw it clearly. It's a contraction. Okay. So the flow in from here and flow out through here. Educated guess, let me ask you, so we haven't reached that point yet, but do you know it's the flow is increasing or decreasing? The velocity is increasing or decreasing going through this nozzle?
Increasing.
Increasing, right? The area is smaller. The flow rate has to be the same. So if the area is smaller, if your speed is increased. Okay, good. Okay. Let's say this, the velocity here at the inlet is 1 meter per second. Let's use U, okay? So that tells you it's a 1D problem. Let's say, assume it's 1D, okay? Well, in reality, of course, it's not absolutely 1D, but let's make our life a little bit easier. 1 meter per second, okay? Outlet speed, U at the outlet, well, increased, right? Let's say, what's the number I use? 4 meter per second, okay? Okay, you are going to do with me, okay? Please pay attention in my class. It's only 1 hour, 15 minutes, please. You do with me, okay? Let's say the length, $18 meters. Length of nozzle, 18 meters. Okay. I want to find, okay, the velocity linearly change. This is also an assumption we can make. Linearly increase. Probably you don't want to make the assumption like this in the real life, but let me just tell you this velocity is linearly increase. Okay, make our life a little bit easier. Okay, velocity linearly increase, right? You know what does that mean, right? Okay, first order increasing. Okay, the goal is to find the acceleration in the middle of the nozzle. What is the acceleration here? You can say it's a vector, but it's a 1D, so it's okay. Let's see. Acceleration in the middle of this nozzle. What is it? Okay, I put a question mark here. Okay.
2 meters per second?
No, don't, it's not. Acceleration, okay.
Okay,
even velocity is not this, okay. Acceleration in the middle of the, okay. So I'm just, I don't want the answer at this moment. I want you to have a thought process, correct thought. What do we start? Okay, if your engineer assign a job like this, okay, what do you need at the first?
Equation?
Yes. What kind of equation? My question is this. Okay, you are calculating acceleration. What do you need in order to calculate acceleration?
Time.
Come on, following what I said previously. Okay, if you want to calculate acceleration, what do you need?
The velocity.
Is the velocity value or a velocity expression?
It's an expression.
That's right. A velocity value.
Velocity field.
A velocity field. An expression of velocity. The velocity value doesn't help you. Okay. Josh said velocity 2 meters per second, but it's not really 2. But you can find out what the velocity, because I said it's a linearly change. So it should be 2.5. Do you agree? Okay, velocity I can get instantaneously. It's average between in and out. Okay, average 1 meter, 4 meter, 5 divided by 2 should be 2.5 because it's the linearly change. Okay.
Oh yeah, I went from 0.
Yeah, yeah. So it's a piece of cake, right? But that doesn't help you. Look at the expression here. Okay, even it's 1D, but still you need an expression for the velocity field, how the velocity changes. Okay, because you need to consider the convective acceleration, how the velocity changes locally, then it contributes to the acceleration. Okay, one value of velocity doesn't help. Okay, so based on this knowledge you learned, you know you need to find a velocity expression for this nozzle. Okay, now I was given only the values, inlet 1 meter per second, outlet 4 meter per second, even the middle point, I can say it's 2.5 meter per second. So, but what is the expression for velocity? Without that expression, without the velocity changes. So it changes with your x dimension, right? So you need to find out that expression before you even attempt to calculate the acceleration. This is the thought process. Okay, guys? Okay, you need to have a big picture. You're an engineer, you see the problem from the big picture, okay? So big picture is you really need to find out what is the velocity distribution. If you have an instrument, you probably need to measure every point to find the correlation velocity in terms of x, okay? If you don't have an instrument, let's challenge my math. See if I can find out the velocity distribution, velocity function, expression, okay? Everybody, did everybody follow me? I want everybody on the same page. Okay, so how to find the velocity expression, I will tell you in a minute, but everybody, do you agree? We need to find that, okay? So that's important. So how to find that? That's my question. So go first. Go 1 to find velocity function, expression, whatever you want to call it. Okay, so you know velocity is a function of x, so you need to define your x coordinate before you do anything, right? That's the sure thing you need to do. So let's say this is our x coordinate. You need to have the origin, right? Let's put the origin here in the beginning of the nozzle, right? That's common sense, is that right? You can, if you want to put the origin in the middle of the pipe, it's okay. It should be the same answer. But if I were you, I would put it in the beginning of the domain, inlet at 0. At least I can get rid of, maybe I get rid of one turn or something like that. Okay. Okay, x coordinate and the origin. Mark clearly on your paper. Okay, 0, origin, x coordinate. So every location along the center line here, you will have an x coordinates, right? Only 1D, this is a 1D. So I know my equation is not that difficult, okay? So how to find the expression, okay? My only hint here is a linearly change velocity. So it's a linear function for velocity. What is the form of the linear function? So u is linearly changed with x, is that right? So what is the general linear function looks like? What does it look like? Anybody? Don't be afraid to use letters. If you don't know anything, put a letter there, okay? That makes sense? You have to be something x, right? Yes, go ahead.
du over dt plus u over...
No, it's a linear function. Don't you think too complicated? It's a linear function. So velocity u linearly change with x.
Oh, okay.
So what does it look like? A general linear function. What does it look like?
Is it 1 plus x over L?
Slope times x.
Slope times x then. Yeah, you're right. You're halfway. It's not complete.
mx plus b.
Yeah, right? You need plus b, right? Is that right?
Oh, yeah.
Yeah. If I were you, I just write ax plus b. Okay, I just like to write down on my paper something. I don't want to think in my brain, you know, in my mind. It's easier to write it down. So I write down the linear function. It will be look like this. I don't know a and b. Okay, since the problem tell me the velocity linearly change. Okay, so u is linearly change with x. Everybody agree? Everybody with me on the same page? So if you can write down this line, actually you're halfway through. That means you have the right direction. You should be able to solve it. Okay. The next item is here is how do you find out a and b, right? You just need to find out a and b. Do you agree? If you find out a and b, you have the function of u in terms of x. You have the expression. Then you can go take derivative to find out the acceleration. Do you agree? Okay, I can write it down here. See, your acceleration is right. I'll leave it to you maybe to calculate the acceleration. I'm helping you here. Okay, so ax plus b. Okay, how do we find a and b? Okay, that's the task, right? It's relatively, no, I shouldn't say it's difficult. It's not difficult, actually. How do we find a and b? So what is the strategy? Have you ever attempted in your life to find a coefficient for the linear function? I think you did, right? In high school, you did. In college calculus, that probably did too. How do we find a and b? What's the strategy? You don't have to give me answer. You know, I don't care answer. What's the strategy? What is the thought process? How? What condition you want to use? What information you want to use to find a and b?
Is it like a rise over run type of thing, or are you like?
No, look at the problem statement. So you're solving a problem, you have to focus on the information given. Okay, you're not going to use any information outside the information that gives to you, right? So look at the information you have now. I put everything on the drawing now here. Okay. What information given that can help you to find a and b? Focus.
We know u at 0 and we know u at 18.
That's right. At x equals to 0, your u is given. Is that right? That's why we need a coordinate system, clearly defined coordinate system. So you know an x value and you know a x value at the outlet too. Is that right? Is that helpful? Okay, at the right? At x equals to what, 18 meter. What is velocity? 4 meters per second. Okay, you have two unknowns, a and b. So you need two equations to solve two unknowns. Do you agree? Everybody, do you agree?
Yes,
Okay.
sir.
Are these two equations here based on this two set of conditions? Can you substitute x and u to find out a and b? So that's the first task of the quiz. Okay, find a and b. Okay, go ahead, do it now before we continue on the next step. Substitute. Okay, a equals to what, b equals to what I want you to find. Okay, everybody, can we do it? Any questions here? Okay, write clearly on the paper. Eventually I want you to submit to the paper. Okay, just go ahead now. Then stop there. It won't take you too long. Go ahead. Okay, you probably need to turn on your video. Okay, it's a quiz, so let's make it still. Yeah.
Oh, this is a quiz?
Yeah, this is the quiz. Just go ahead, calculate A and B. I give you some time. I'll wait everybody to finish that, then I'll continue.
Do you want us to submit it when we're finished?
Not yet. I want to submit at the end. This is not finished the problem yet. Okay, I will continue after you finish the A and B. Oh, yeah, I will keep you going through with you, so don't worry. I just wanted you to learn something during this class. So if you're done, just how to say, maybe just sit up, let me see your face, and yeah, I know you are done. That's not difficult, right? Everybody have the points here. This is a 5-point quiz. It's a small quiz, so I want everybody get the 5 points through with me. Okay, it can help your score. I give you opportunity, right? Good. I see most of you did it. Okay, let me wait for a minute. Okay, seems like everybody's done. Okay, good. Let's continue. Okay, I put on next page. I can draw this again. Make sure I don't have to switch back and forth. X, U equals to 1 meter per second. U equals to 4 meters per second. Okay, this is 18 meter. What is acceleration here? All right. Okay. So now you have an expression. U equals to AX. You have the A. You have the B. Okay. You already have it. Okay. So now write down the equation for me. Write down the equation for me. Actually, I want you to, write down the acceleration equation. Right now, write down the acceleration equation. Okay. I want you to write the equation without even putting U and V. Just use U. Okay. I think the task is here. I have the 3 equations here. Okay. Are you looking at me? Okay. Pick green box or blue box or red box? Okay, I want you to make a decision. And if you pick the box and write down that equation or equations, depending on which box you pick. Okay, write it down, just write it down. Don't put the U in there yet. Just put UTX, okay? I just wanna see you have the correct equation selected for this problem.
Okay. Submit this as well.
What'd you say?
You want us to submit this as well?
Yeah, this is the paper. On the same paper, you write a continuous writing, and eventually when you submit what you write on the paper. Okay, for the whole problem. But I just want to go through with you. I want to ensure everybody scored the 5 point today. If you didn't come today, then it's your loss. Okay, so did you write it down, everybody? Did you pick the correct equation to start with? Okay.
Dr. Zhang,
yes.
Dr. Zhang, I lost you there for a second. What's this next part? I'm sorry.
Oh, that's all right. Did you see the screen here? You have an equation for acceleration.
I heard you talking about we need to put something down, and I'm just trying to figure out what you were saying.
I want you to put down, select the correct equation, either the red box or green box or blue box.
Okay.
Okay, make that decision and then write down the correct equation or equations on the paper before you put in value for you.
Thank you.
Partial U, partial X. Okay. I just want you have the correct direction. Did you write it down? Oh, that equation, okay, I gave points. I need to check that. Okay. Now in the equation, you will have U and partial U, partial X, or partial U, partial Y, whatever, right? Okay. So can you find out the U for me first? What is U equals? So you have the dimension, it's the middle of the duct. Your X of the middle of the duct is 9. Okay, maybe it's not 2.5, what we said previously, okay? But I want you to find out, since you have a expression for U, can you find out the velocity on a particular location, which you know? Okay, this is the next step.
Professor.
Yes.
The length of the pipe, is that 18 meters or centimeters? Because I calculated
18 meter. 18 meter. Everything's meter here.
I calculated it thinking it was centimeters, my bad.
Okay, so it's meter. You just change the unit in your calculation. I don't think it matters that much, right? Okay. You do need the U value, right? Exactly U value on that point. Okay. And the next items I will grade is what is the partial U, partial X on that particular point. Okay. Or something else like a partial U, partial T, partial U, partial Y, partial U, partial Z, if there's anything available. If it's not available, you don't need to write. Okay, I want you to make the decision. Although it's so obviously, I already gave you the answer. Okay, go ahead. Okay, this is everything I'm put on question mark, then I will give points. Okay. U, what is U? Okay, what is partial U, partial X? Okay. And the final answer, AX, what is that? Okay, AX on the middle of the nozzle. Okay, so these are the points I want to give. Okay, is that clear to everybody? Everybody can solve it? Everybody can score the 5 out of 5 for this one? Okay, I'll give you some time to complete it. Actually, you can ask questions. I have no problem answering any question. other than give you the actual answer. Give you the result solution for this problem, but I can answer questions, okay?
Professor?
Yeah.
We said earlier that U, V, and Y are characteristics of velocity.
U is just the velocity, X component of the velocity. It's just velocity. Okay, it's for this problem, it's 1D, so you don't have V and the W. Do you know vectors? I can tell you're probably not familiar with vector. Okay, velocity has 3 components, U, V, W. Okay, so this problem only have U. That's why in the drawing, I said U equal to 1 meter, U equal to 4 meter, right? Yeah, I like to be clear. Any question is a good question, okay, don't worry. Okay, I give you a couple more minutes to finish it, and let me open the summation site here on Moodle so you can submit after you finish, okay? I give you plenty of time. You're holding it. If yeah, it take me some time to. Computer is slow. Just double check your calculation, everything. Make sure you score 5 out of 5 today. Okay. Everybody done? Okay, I think the summation site is on. Okay, if you're done, go ahead and submit. I give a couple more minutes if you haven't finished. Any questions? Okay, don't be afraid. Go ahead if you have any questions.
Did you give us a time?
Oh, do you how many time do you need? I give let's say 10, 20, around 10, 20 now. How many minutes do you need? 5 minutes?
I meant a time as in t in the equation.
Oh, that's a good question. Look at it yourself. I think the problem statement is clear enough. If it didn't give you, what does that mean?
Steady flow.
I don't want to answer it. Your classmate answered it. I don't know if it's correct or not, but you make your choice. Okay, if you're done submitting, just raise up your face. Let me see your face. Then I know you're done. Okay, we can continue. It's not the end of the class yet. We need to continue other materials.
Can I get a couple more minutes or my connection is bad?
Oh, yeah. Okay, no problem. It still have 3 minutes. It's only 10:22. So my grading point is here is A and the B, okay? Each will have points, okay? A and B, okay, each have points. Then the equation here, AX equals to what? The equation, that will be a point, okay? And then find out the U, that will be point, okay? Find out the partial U, partial X, that will be point. The final answer for AX, that will be point. Okay, these are the 6 places I will give points. I don't know how to distribute it into 5 points, but I will do that later. But these are the points, okay? When I grade it, you better know how I grade it, right?
Yes, sir. Professor, I'm still scanning mine now, so it may come in a little bit.
That's fine. You done it, right? You already completed it. You're scanning it, right?
Yeah, yes, sir. I'm scanning it right now.
Okay, that's good. I just wanted to, I just need to start the lecture. You know, I always still have 20 minutes to go. So I will start lecture 10:25. So go ahead. You can still have time to submit. Everybody, is that okay? Done it? Okay. Arthur, you done it? Josh, did you do it? Complete it? Okay. Everybody? Okay, let's see. Dylan, I couldn't see your screen. Did you finish it? Jamal, good? Okay. Megan? Yeah, good, okay. I missed a couple of names. JC, okay. Bijaya, okay. I think everybody's done. Good. Okay. Let's continue. Now, today's new topic. Okay. Today's new topic is this. Now, you know how to calculate acceleration. Now, let's do the important thing. How to relate your acceleration into force. Okay. Not force. Actually, in our class, we deal with pressure more, right? If you can calculate pressure, you can convert it into force. No big deal. So next topic is called Euler's equation. The Euler's equation, the sole purpose is to convert the acceleration, which you calculated from the movement, the velocity, into the pressure. Okay, so let's start let's spend some time, one more time on this finite element, infinitely small element. You remember we in the hydrostatics, we did that, right? Okay, so this is the length, delta L, okay. So, and remember we called the P delta A. That's exactly the same as last time. The only difference here, now we have the acceleration, okay. P plus delta P delta A, right? You have a acceleration along the L direction, let's say, okay, AL. The fluid is moving, okay. So the force balance. So you have, again, you have a weight, you know, right? Remember the same thing, right? You have components of the weight. Okay. Do you remember the expression for weight, right? Now, summation of F in hydrostatic, we did exactly the same thing, is equal to 0, remember? Summation of F along the L direction. Now it's not, right? It's equals to M times AL. Okay, this is the Newton's second law. Okay, as I mentioned earlier, F equals to ma. Okay, basically it relates the acceleration to the force. Okay, so what does M looks like? Okay, let's expand this form. M is what? M is rho delta A delta L. Delta A delta is volume, right? Rho volume, that's mass. So let me expand this equation. It's similar to the hydrostatic, just the right-hand side, you have more terms, right? The W, okay, sine alpha. Again, this is the alpha, right? W sine alpha, it's the component, that component, okay, equals rho delta A delta L AL. Okay, similar to what we have last time, except the right-hand side is not 0 here. Okay, so we can cancel the terms. Delta P over delta times delta A minus W is gamma delta L delta A. Remember, gamma volume is the weight. Okay, you have to memorize those equations. Sine alpha equals to rho. Okay, hold on. Delta A delta L AL. Okay, then we can cancel those delta A's. Okay, this is the derivative. I just go quick. All right, it's the second time we do this. Delta L minus gamma. Last time here equals 0, right? But here is not, right? Okay. So what's the next step? So again, sine alpha. Remember what is sine alpha? Delta Z over delta L, right? So let's make it a partial derivative. So partial P over partial L minus gamma partial Z over partial L equals to rho AL. Okay, so let's group them together. Negative partial over partial L P plus gamma Z equals to rho AL. Or maybe you move the negative sign to the right-hand side. Negative rho AL. Okay, so this is the Euler equation. The difference between last time is right-hand side. Last time in hydrostatics, there's no acceleration. Acceleration equal to 0 is a special case for Euler equation, right? Basically, the Euler equation is more broad, more general than the hydrostatic equation. If you substitute AL equal to 0, then it becomes hydrostatics. Remember hydrostatics, right? Partial. The reason last time the P plus gamma is equal to constant is because right-hand side equals 0. So the partial over partial L in the left-hand side, you can get rid of it. Okay. Anybody? Do you remember? So because you have a right-hand side, it's non-zero, then you have to keep the partial L in there. Okay. So this is a more general form. Okay. We call it the Euler's equation. Okay. And so here you have something not good for you to solve. Okay. You have an L term here. Okay. First of all, one thing not good is this is the differential equation. It's not like hydrostatic. Hydrostatics is actually it's an algebraic equation, right? Okay. Do you remember? Okay. Now, since the right-hand side is non-zero, we have to keep this form. Okay. And it's a differential equation, partial L. Okay, equal to something. Although it's not that difficult differential equation. Okay, but still, it's a different differential equation. So with the acceleration, you have to solve a differential equation to solve the problem, to find the pressure. Okay, but this is the Euler equation. I'll show you how we apply the Euler equation. Use examples. Okay, but this is the equation. When you write down the equation, be careful. That derivative, partial derivative, has to be exactly on the same L as the direction of the acceleration, AL. Okay. When you examine this equation, you should find there's something you have to take care of, which is the L. So in the problem, you have to define, you have to know what is your acceleration direction. It could be X, could be Y, could be Z, could be any cylindrical coordinate system. It could be R, could be theta, okay? It could be any direction. Then that dictates you what is the derivative in the left. You have to take the derivative along that same direction. Okay, did you see my point? Without doing this correctly, you have no way to solve the problem. Okay, you have no way to solve a example problem or whatever problem using Euler's equation. That's the key point. How to solve the differential equation, you know it. I will show you in a minute later. But when you write the equation, you have to be 100% sure, 100% clear that derivative, okay, partial L here has to be exactly the same as the acceleration direction. So based on the problem, what direction is your acceleration? You take derivative respect to that direction. Okay, I'm emphasizing it here. Okay.
Professor, what's the derivative of acceleration? Because I know with velocity, acceleration.
No, any acceleration can be any direction in the real world, right?
Yes, sir.
So if the problem gave you, say, the acceleration is in the y direction, then your derivative is in the y, partial y then.
Oh, okay.
Okay. I try to convey is this. You have to be careful. The derivative, you don't know what derivative you want to do. It's a differential equation. So when you write down the equation for that particular problem,
yes, sir,
you need to be really, really careful on this.
So it all depends on the direction.
Yeah, it depends on the acceleration direction. Okay.
All right. Thank
That's a good point. Yeah, I just want to emphasize this here. Yeah, good. Okay. Okay, let's look at a simple example using this. Okay. Let's let you feel what is Euler equation problem look like. Okay, let's look at the textbook example. Let's see. Textbook 4 point what? Let's see, 4 point acceleration. Euler equation. Yeah, let's do 4.2. Okay, it says this. It says it's a piston. Okay, it's a piston. They're pushing a column of fluid on top of the piston. the piston moves high speed, 100 meter per second square. This is acceleration unit, right? Meter per second square. Okay. Move up. This water column, the fluid column is 10 centimeter. It's water. Okay. Practical, very practical problem. You design a piston in the car, engine, you know, it push very fast, right? Move very fast. So the question is here, okay, what is the force or pressure I feel on the piston surface? Okay, think about this, the reality for this application. Does that make sense to you? You're moving up really fast. Okay, is the surface, piston surface gonna experience a lot of pressure or force? Right? It's a common design problem. So if you design something related to car engine, the piston, you probably need to know what the force the surface is gonna experience. And you
What's
need to
the
know
acceleration?
100 meter per second square. Okay. You have to know what the force you will feel. Then you can design the surface, design the piston to make sure it can withstand that amount of force. Is that right? Is that the thought process if you are a designer? Okay. You see, everything design, engineering design is not like a fashion design. You're basing, oh, whatever I like, or no, it's from your calculation. You make sure it works, right? Is that right, everybody? Do you see the process? The purpose of this problem is to calculate the force on the surface when it moves at 100 meters per second square with acceleration like this. Okay. So this problem is a very typical Euler equation problem. So how do we apply the Euler equation? Now after you apply this, after you solve this, you probably will feel, oh, okay, that's the meaning, physical meaning of a differential equation. Okay, I guess a lot of students lose the bridge, lose the connection between calculus and the engineering applications. Okay. I don't know if I can finish it, this problem, but let me at least start it. Okay, so you're gonna write the equation for the fluid column. Okay, for the fluid column. So your equation will be your acceleration. It's 1D, so you can have actually use D. Okay, P plus gamma Z. You don't know what P and what gamma is. It doesn't matter. Write it down first. Negative A. What is the direction you want to say here? Z. Okay, vertical direction, right? So it's AZ times L. No, I'm sorry. It's not AZ times L, M times M, right? Density, rho. Okay, so what is D over D here? What is the denominator? What should be the independent variable? Okay, the Euler equation, you just write P plus gamma Z. Don't worry about it, just write it down. Okay, I'm just helping you to solve a problem, how to apply equation to a particular problem. Okay, since the acceleration direction is in the Z, AZ, I write it down here. See, I write the right-hand side first. So what's the derivative here?
Partial Z.
Yeah, you can just say D, right? It's one dimension, total derivative is fine for this one. Okay, good. You're right, Arthur. D over dz, careful, okay? So now you have a differential equation, okay? Then you can solve it. So how do we solve it, basically, okay? See, the most difficult part is just apply the equation to a particular problem. When you see a problem like this, you need to know you're gonna apply the Euler equation. If you know, you're halfway through the problem, okay? How do you solve it? Okay, if I were you, I will move the dz to the right-hand side. So d p plus gamma z az rho times dz. Then I take integration, right? Is that right? Did you have the differential equation class yet? When you solve differential equation, you need to take integration. Is that right, everybody? Okay, so this is how we take integration. Okay, so after you put the integration sign, you need to give the limits, right? That's the way you calculate differential equation. Okay, limits. What are the limits? I think the key is the limits. Let's say z first. What is the dz's limit? So
0
I guess
to 10.
0 to 10, that's fine. Yeah, 0 to 0.1, how about that? Let's use meter. Okay, correct. Okay, so how about the left-hand side? So it's a P plus gamma. See, it's hard to say. So let's say from my location 1 to location 2. How about that? You know you're doing the Euler equation for that water column. So you have to specify for Euler equation, you have to specify the 2 points to it, just like hydrostatics. 2 ending points. So this is the Z. In the right-hand side, the limits are the Z1 and the Z2. Is that right? Z1 is 0, Z2 is 0.1, right? So in the left-hand side, I'm not sure what can I write down here. Let's put 1 and 2. Let's take integration first. Let's see how it goes. Okay, so
0 to P.
actually P1 to P2, Z1 to Z2. You have 2 terms there. Both of them will be 1 and the 1, 2, and 2. Okay, but let's do it. So left-hand side, it's 1D, right? Integration. So can you do the integration of integrate of 1 times D something? It will become just P plus gamma Z, right? 1 to 2. Okay, right-hand side, AZ and rho both are constants. You can move it out. These are constants. Okay, it becomes 1dz, basically is z, okay, 0 to 0.1. Okay, same order, be consistent. You know, in the right-hand side, it's from 0, bottom to the top. In the left-hand side, also from the bottom, section 1 to top, section 2, okay? So right-hand side has no problem, right? You can easily do is negative acceleration going up, so it's positive 100 meter per second square. Density of water is 1,000, right? Cubic meter per second. Oh, no. What is density? Kilogram per cubic meter. Z is 0.1 minus 0. It's just 0.1 meter. Okay, right hand side, everything. What's the left hand side? So it will become P2 plus gamma Z2 minus P1 plus gamma C1. Okay, that makes sense to everybody? I'm out of time, but here, right-hand side, everything is known. What is the left-hand side? Do you know everything? P2 is 0 on the top surface, open to atmosphere. Z1 is 0, right, in the coordinate. So Z2 is 9800 is gamma times Z2 is 0.1 minus P1 equals right-hand side. So that equation only have one unknown, which is P1. You can calculate the P1, pressure on the surface of the piston. Okay? So this is the whole process of solving all equation problems. You need to write down the differential equation, solve the integration, and solve the unknowns. Okay, we will do it more on next class on this topic. Okay, but hey, luckily I completed this example. Okay, we'll continue next time.
So before you go, P1 is equal to 980? I
don't know the value yet. You see, you know everything in the right-hand side, right? Do you know? And in everything in the left-hand side is also given except the P1, so you should be able to calculate.
Oh, okay.
Is that 9800 times 0 times 1 minus P1?
No, it's gamma Z2, right? 9800 times 0.1. What is Z2? Z2 is 0.1, right?
Oh, okay.
Yeah.
Okay. Minus P1 equal to something. So you should be able to calculate P1, right?
Yeah.
Okay. So that's it for today. We'll continue next time.